Okay, we are ready to put it all together. So we know what the number at the end does. It moves it up or down. We know the number inside the parentheses moves it left or right. This tells you whether it opens up or opens down. And it also tells you if it is wide. If it's a fraction, it's going to be wide. A fraction smaller than 1. Or a decimal, and it could be skinny as well. So it could be wide or skinny. Skinny is if it's a number bigger than 1. Right now we're going to deal with 2. Let me zoom in so you can see them better. We're going to deal with 2 that don't have an A in front. So we're just going to deal with the H and the K. Remember, we're always comparing to the normal graph, which starts at 0. And so we're going to be moving these guys around. So let's look and see what we have right here. So I'm going to get my little pencil here. We're going to look at number 4. And then we want to be able to plot some points and draw our little parabola, right? Now then, minus 5, remember from yesterday, minus 5 means right 5. And minus 3 at the end means down 3. So when it tells you to describe it, that's what they want you to do right here. We want to describe it in words is what I want. Okay? So I am going to say that this one is right. We're going to go right. I have a thin line here, maybe? Is this thinner? Whoops, not really. Maybe this is the thinnest. Let's see. Let's go back and get rid of that stuff. Okay, so we'll use this one. And we're going to say, we're going right, R-I-G-H-T, right, 5. And we're going to go down 3. Okay, so right 5, 1, 2, 3, 4, 5. Down 3, 1, 2, 3. Well, see, what does that mean? That's the vertex. I know exactly where the vertex is. So I can describe what happened because I went right 5 and down 3. Now I want to graph what's going on, and I know where the vertex is. Now remember, this is a normal size graph. There's the number in front up here doesn't make it fat, doesn't make it skinny. It's a normal graph. And so that means from here, I'm going to go over 1. Over here, I'm going to go over 1. Then from the vertex, I go over 2 and up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. I can go over 3. I got to go up 9. That's 4, 5, 6, 7, 8, 9. I go over 3, 1, 4, 5, 6, 7, 8, 9. Look at where I have. I have a beautiful parabola that does in fact go just like that. Alright? Now, you can find each of those answers by doing what I did. Over 1, up 1, over 2, up 4, over 3, up 9. Or you can do this where you plot some points and you say, okay, if I'm at 5, negative 3, where am I going to be if I go over 1? Well, I'd be at 6. So I put 6 in here. 6 minus 5 is 1. 1 squared is 1 minus 3 is negative 2. And look, that's where I put the dot, right there at negative 2. Negative 2. If I go right again, I could be at 7. 7 minus 5 is 2. 2 squared is 4. 4 minus 3 is 1. That's where I put that dot. So no problem. All right? Let's look at the other one. let's clean off this stuff. Okay, and now then we'll look at this one. This one says plus 8 and minus 9. Plus 8 means left, so I'm going to write that I go to the left. Here, let's clean this out. Let's keep on getting rid of my stuff here. So we have room. All right. So we're going to the left. 8. And we're still going down. And we're going to go down 9. So left 8, 1, 2, 3, 4, 5, 6, 7, 8, and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. Okay, remember that's the vertex. We know exactly where the vertex is. It's at -8, comma, -9. Now, we know that because it's the opposite of this, -8, and exactly that, -9. Over here, remember, the vertex was at 5. 1, 2, 3, 4, 5. 1, 2, 3, down there. So the vertex was 5, -3. And the reason, remember, it's the opposite of this one and exactly that one. Okay. So, once again, just like, let's back up here a little bit. Just like on this one, if I go over 1, I go up 1. I go over 2, I go up 4. Well, that's what I want to do on this guy right here. I'm going to go over 1, up 1, and over that, and then over 2, up 4. Let's see, 1, 2, 3, 4. Okay, and then 1, 2, 3, 4. And then over 3, up 9, that would be right there. Over 3, up 9, that would be okay. Remember, this goes just like this. I am done. So, did I do everything I needed to do? Yes, I described the transformation and I graphed it. Perfect. So, let's do 2 more and then we'll be done. I gotta get all this done, all this away. And while I'm doing that, we will, we will put this on here. Yeah, that's what I'm doing. Maybe I can't do anything, can't do 2 things at once, huh? That's probably what's happening. Okay, here we go. We'll try one more time to do it right. And maybe what would help would be if I held it down. There we go. We'll just tape it. Happy days for us. Okay. Now then, look at this. It needs to look like our original problem up here. Let me cut that off so we can see that, baby. All right. So I have something at the end, I have something in the parentheses, and I have something in front. So I'm going to zoom in on this one. And I can see, wait a minute, there's no parentheses in this one. So that means that this number is the k number. It's the number at the end. It moves it up or down. And this number is times x. That's the a number. That tells us whether it opens up or down. And it also tells us whether it's wide or skinny. So let's look at the number again. And we can see that it's -6x. So if I was going to write this the way it looks over there, I'd have -6. And then remember, there's no parentheses here. So there's nothing added in the parentheses. And so I'm going to say I'm at nothing. Nothing in the parentheses, just like that. And then -3. Now it's easy to see that the, well, let's just start the front here. The negative means that it opens down. That means the parabola is going to be upside down. And it opens down. The 6 means it's going to be skinny. So it's going to be an upside down skinny parabola. And then the 0 means it goes sideways none. And so we're not moving left or right. And then the negative 3 moves, it goes down. So if I move 0, down 3, 1, 2, 3, right there is the vertex. So that means that my vertex is in fact 0, negative 3. So I'm going to write it just like that. 0, negative 3. Now then, we know that on the regular graph that we go over 1 and up 1. But this is not the regular graph. In fact, this one's 6 times taller than the regular graph. It's stretched 6 times longer. And it's upside down. So if I'm at 1, if I put 1 in here, or I could put 1 in here, 1 squared is 1. 1 times negative 6 is negative 6. Minus 3 would be negative 9. So here I am at 3. 1, 2, 3. Right there is 1, negative 9. Well, I know it's symmetric, so negative 1 is also negative 9. Now that's all that's going to fit. I could go 2. If I put 2 in there, 2 would be 4. 4 times that's negative 24. Negative 27, I'd be way down here and have to be drawing my dots way down past that. You know, it's not going to fit. So I'm just going to sketch my picture right here, boom, and then come back down. You can see that's a skinny parabola. Very skinny, upside down parabola. Now then, let's look at this one over here. What's going on with this one? Well, here there was something added at the end, but look, there's nothing added at the end, and there's nothing inside parentheses. So that means if I rewrote that one, if I would rewrite that one, let me get rid of all this other stuff here. We'll just get rid of everything we can get rid of. Let's see, that was skinny. Okay. Now then, this one over here opens, the negative tells you it opens down, and the 2 tells you that it's skinny, and then there's nothing added to it, there's nothing subtracted, there's no parentheses. If I was going to write this, I would have, oops, let's get rid of that, that was a mistake. I would have x minus 0, and then I would have plus 0 at the end. What? Yeah. That means that 0, 0. If there's nothing added or subtracted here, the vertex is 0, 0. So here, remember, the vertex was 0, 3, and our parabola was very skinny, and it looked like this. Woohoo! Right? Right? So here the vertex was 0, negative 3. And the reason why is because x number is 0, y number is negative 3. Here, 0, 0 is the vertex. So if I was going to write the vertex, I'd have 0, comma 0. And that's the vertex here. And then it goes down, and it's not as steep as this one. This one goes down. It's twice as long as the normal one. This one was 6 times longer. Right? So, if we do the little chart again, we know that 0 is still 0, because 0 times anything is 0. If I put 1 in there, I'm going to get 1 times that's going to be negative 2. Let's go ahead and put 2 in there. 2 times that would be 4, or 2 squared is 4, excuse me. 4 times that would be negative 8. Right? So I can go over 1, I go down 2. I go over 2, I go down 8. That's 2, that's 4, that's 6, that's 8. The other side has to be symmetric. So that means there's one right there. Now then, this one is a tall, skinny, upside down parabola. Right? It's not as skinny as this one. This one's 6 times This one's only 2 times. And that is the end of putting it all together. So, now you can do your homework.